Architect Ledger TV. Script. Spoken section. You migrate to Kubernetes, check all the boxes, deploy with confidence, and then your entire Spark cluster melts. Not from one misconfiguration, from two innocuous settings that should never have been in the same room together. Today, we're auditing the infrastructure collapse that took down production pipelines, and the architectural lesson hiding inside it. I'm your host on Architect Ledger TV. Let's get into it. Headline: Spark on Kubernetes. 2 misconfigurations, total failure. Here is how it breaks down. After moving Spark to Azure Kubernetes service, 2 settings collided. First, TMPFS, shuffle spill. Means temporary data goes to RAM instead of disk. Sounds efficient, right? Second, hard pod affinity forced every executor onto a single node. Together, that node ran out of memory instantly. In plain English, the shuffle operation tried to dump gigabytes of data into RAM that didn't exist, on a node that couldn't scale horizontally because affinity locked it down. The catch is this interaction wasn't obvious in isolation. Each setting looked reasonable alone. But here's the point. Kubernetes doesn't know your Spark topology. You have to architect that boundary yourself. If you're running Spark on K8s, audit your local.drs config and your pod affinity rules today. Don't let them breed in production. Headline: Microsoft's Majorana 2, Quantum Breakthrough, Shaped by AI. Microsoft shipped Majorana 2 this week. The numbers are wild. Qubits 1,000 times more reliable than Generation 1. Mean qubit lifetime hit 20 seconds. The industry baseline is measured in microseconds, not seconds. That's not incremental. That's a different machine. But here's the structural detail. The entire R&D pipeline that built this used Agentic AI to optimize the qubit design space. Instead of humans guessing, AI agents ran thousands of simulations, identified failure modes, and converged on solutions faster than traditional research could. That detail matters because it signals a shift in how hardware breakthroughs happen now. The chip didn't just improve. The process to build chips improved. If you're in quantum or materials science, the playbook changed. Study how AI agents guided this. It's the template for the next generation of hardware research. Headline: Linux optimization. Old OS, fresh tuning. A decades-long Linux practitioner published 8 concrete optimization tips for Zorin OS. Stuff like disabling unnecessary services, tuning I/O schedulers, tweaking memory management, cleaning package bloat. Nothing flashy. But that's the architectural point. Operating system performance isn't about the newest version. It's about knowing which knobs to turn and why. For engineers running Zorin or any Linux distribution in production or on workstations, this is a reminder. Baseline performance is 80% misconfiguration, 20% hardware limits. Audit your services. Check your I/O scheduler. That matters because most OS slowdowns come from settings inherited from installation, not from the OS itself. If your Linux box feels sluggish, this is the diagnosis framework you need. Headline: GPT-5.6. Leak Qwen 3.7. Plus, the model velocity continues. GPT-5.6 leaked. Qwen 3.7 Plus dropped. A new desktop AI agent app emerged. Hermes is shipping. The pace is absolutely relentless. In plain English, the model release cadence has hit a rhythm where waiting 6 months for a new version is already dated. Each release claims faster inference, better reasoning, lower latency. The structural catch here is deployment. Every new model requires validation, fine-tuning, integration testing before you ship it to production. Companies are announcing models faster than teams can evaluate them. That brings us to the real bottleneck. Not model capability anymore, but the infrastructure and process to safely adopt them. If you're building AI products, your real constraint is no longer, do we have a good model? It's, can we integrate and validate updates fast enough to stay competitive? Focus engineering there. Headline: AI drug discovery race. 2026 becomes the deadline. The pharmaceutical industry is spending billions on AI drug discovery platforms. The bet is simple. AI can compress years of molecular screening into weeks. Breakthrough compounds that would take humans a decade to find might emerge in months. The architectural stakes are enormous. Success means faster medicine to patients. Failures mean sunk capital with nothing to show. That detail matters because drug discovery is one of the few domains where AI speed actually translates to human impact. People's lives depend on whether this works. The 2026 timeline matters because that's when early AI-discovered candidates should start showing clinical results. If they don't, the entire bet looks reckless. If they do, it reshapes how pharma operates forever. This is where AI's promise becomes real or gets buried in failed hype. Read the Spark on K8's failure audit on InfoQ. 8 minutes. Deep dive into pod affinity and TMPFS config if you run distributed systems on Kubernetes. Essential pattern recognition for your next outage. That's 5 stories reshaping infrastructure, quantum hardware, Linux ops, model velocity, and medicine. What's your biggest infrastructure near miss this year? Drop it in the comments. Subscribe for more audits. See you next time. End spoken section.